Next up, we have Ite Consult, and they're going to talk about integrated demand planning and production optimization in a cloud service. And please welcome David Kennedy.
Hi, hello. You hear me?
Yes.
Okay. So thank you for having me here. It's not the first time I'm in a AnyLogic conference, but it's the first time I'm remote. So uh, I am the co-founder of Ite Consult, and we are a company that is focused on PI. We have an extended experience. I mean, many years working with SAP implementations for large companies. And today we are more focused on the cloud planning solutions that are integrated with AnyLogic and Gurobi that are our software partners. And we are offering this to customers as a service. So there are many benefits of doing this. We believe it's one of the ways we can help companies adopt new technology, even if they don't have the infrastructure or the skills internally in-house. So when you're working on the cloud, everything is included, and it's a faster time to value approach, and it's a feasible for any size company. So it's not only for some of the larger SAP customers. So what we're going to see today is a business case from one of our latest customers. This is Functional Beauty, and we want to explain what the problems they had, how we solved it, and guide you through the different steps of the process. And if we have time at the end, I would like to show you some demos. So the problems. Functional of Beauty is a fast-growing company in the hair and body care industry, and they were looking for us to implement the sales and operation planning process and a supporting technology to be able to improve the way they were running the demand plan and supply plan. The problems that they had is that they were doing everything in like silo planning ways, mostly Excel and very different aggregation levels. So this made it very difficult for them to come up with a production plan. They only had 2 weeks projected moving forward, and the way they were working, they had over inventory in almost every level, so finished good, raw materials, and packaging. They wanted to bring that to a safety stock level. So that was a big issue. They also started to have some labor restrictions, and this is happening everywhere. But we started this project at the end of last year, and labor was already a problem. And on the other hand, they were expecting a big increase on their retail business because they have two production models: DTC, that's direct to consumer. It's more a make to order type of production, and they have a retail business. It's a make to stock, and that's selling through some of the big retailers. The two processes share the same production process. I mean, the same type of production levels, the same raw materials. So we had to have something that could run differently, but also integrated between the two models. So what we proposed as a solution was to use the sales and operation planning solution on the cloud and integrate it with a simulation and optimization model that we built with AnyLogic and Gurobi. So the planning was done with SAP Analytics Cloud. That's a planning platform that SAP provides. And the solution that we provided to them was first handle all the data. So we created a single point of truth for them with all the relevant data for this process, historical data, budget, forecast, and more importantly, we transferred the government of the master data to the business user, because this is typically done by the IT department. But in a planning process, it's important that the user can create data for new products, new clients, and do it on the fly. On planning, we implemented the sales and operation planning, so we give them all the functions they needed to be able to plan at different aggregation levels, custom levels, hierarchies that they could create on their own. On the simulation side, we created a model that would allow them to run a rough capacity plan and play with different and very different scenarios. They wanted to be able to handle different demand inputs because they had different projections, especially in the retail business. They wanted to be able to set their production capacity, how many plants, how many lines they had, their rates for SKUs, and they wanted to be able to work with the labor restrictions. So the model had to take this into account from day one. And they also wanted to have the cost included in the optimization process, because if they were going to build inventory ahead of time, they wanted to be sure that they did it in the best possible way to reduce the inventory costs. So those are all the components of what we proposed as a solution. If we look at the process and the technical platform, and most of you know how sales and operation planning works, but this is a monthly cycle. So they repeat this every single month. And it starts with the demand forecasting. And we prepare the tool for them to be able to run this very, very fast and easy, in an easy way. And then they added the building blocks to their statistical forecast. Then you go into demand planning review, where you discuss the results with all the members of marketing, sales, and even finance. And then once the demand plan is approved, they go into a simulation or an optimization cycle, where they as I said, they maybe run different planning scenarios, and they add all the constraints. So what's going to happen with labor? What's going to happen with if I'm going to improve this line, I have to shut down this line. So this is a cycle they will run during a few days, and once they have different scenarios that they choose, they will go into a supply planning review, and this is a discussion. It's more operational, so they will discuss and decide which plans are they going to push up to the executive S&OP meeting. So once they get to this point, that's the ending of the process. They're going to approve one of those scenarios as their production plan, and they're going to get on their operational plan, the sales plan, and they're ready to get their finance and purchase plan. So this is basically the cycle that repeats every single month. And the planning, the blue cycle is what we support with with Analytics Cloud, and this cycle here is what we support with AnyLogic and Groovy. So I wanted to spend a few minutes explaining how we did the integration with SAP Analytics Cloud. We have been working with SAP for many years, and the integration hasn't been easy. So we are happy we were able to accomplish this. So the end user will run the simulation model from any device, and mostly it's a desktop. And once they connect, they will log into SAP, and they're going to get, using their credentials, they're going to get a token. So the token is like the keyword or the security requirement to be able to request data from SAP later. So once you have the token sent back to you with the Java, we send HTTPS type of messages to SAP. This has been taken by the API and on the SAP side, and reading the message that we send, where we ask for specific data and models, it would know what he has to send back. This is going to be sent back to AnyLogic using the OData protocol. So basically, we are going to get back a JSON file with all the information that we requested, and that's going to be saved in tables, in the AnyLogic tables. Once this process is finished, and we do this at the beginning of when the simulation starts, we will run the model, and the output of the model will be saved into BigQuery database. It's the way we are loading the data into SAP for the end users. I mean, from the source systems. So this is the way that the data goes back into SAP for further analytic purposes. So it sounds maybe complicated. It wasn't easy to build, but finally this is working, and it's working very fast and very stable. And it's nice to see that you can just click on a button on AnyLogic and get the data from SAP directly into the system. On the other hand, going more into the detail of the optimization model, as I said, we get the input from SAP. We are basically reading 4 different data areas. So we read some tables with business rules. This is what allows AnyLogic to build the plans, the lines, all the resources. So everything is built dynamically. There's nothing created in AnyLogic static. So everything comes from different tables from SAP, and then we will read the demand forecast table with the demand that we want to run. We are going to download the bill of materials, so then AnyLogic knows how to create or produce a product, what raw materials it needs, and we are going to read the latest inventory. So all that is loaded in AnyLogic at the beginning. It just takes a few seconds to load. Then the user is going to set some local parameters in the model, and with this, it's going to create different scenarios. So first, before running the model, what we would do with using Java is create the files that we need to send this information to Gurobi. So we will define the problem for Gurobi, and then we will run Gurobi as a linear programming solver. And once Gurobi finds the feasible solution for this scenario, it's going to come back into AnyLogic. So that's also stored in tables in AnyLogic. So this is the first step, but it's really a cycle. So because every time you change a parameter, it's going to rerun the solver, and then it's going to go back to the simulation. So then we run the simulation with all the information from SAP, the parameters, and Gurobi, and the different outputs of the simulations are saved in output tables that are then sent back to SAP. And what we get from SAP to SAP is a production plan. Usually it's a 12 months or 18 months production plan. We're going to have the full list of raw material requirements. So that's any mix of bulk raw materials, packaging, everything you need for the next 18 months. We're going to have inventory projected for all the different levels of the bombs. And we are going to also load some information on labor and machine usage. So because we have all that detail in AnyLogic, we can know exactly how many people we need in every single step of the process, and give that information back to the user so they can decide and see what labor they're going to be needing moving forward. So going back to the business case, what the planner, if we look at what the planner does every day, this is the way we show the planners live. They're going to be running through the different steps. The system is the process is embedded in the system, so the system is going to tell them exactly what to do, when to do it, when it's due, when it has to be ready. But they're going to go through all this cycle every single month, and supported by the system. So we wanted to look at a few typical scenarios that they run. As I said, they have two. Usually, you have at least two demand forecasts. One is just having the marketing lifts, and the other one is it's a version where they have a bigger raise in the make to stock market, because they're constantly negotiating with new retailers. But because of the size of those retailers, and the time it takes to build up the inventory for a new retailer, they need to start looking into that months before, even before they close an agreement. They need to know they're going to be capable to create the inventory, the build up of the inventory for that retailer. So that is something they are always looking into as a possible scenario. And on the operational side, I mean, their biggest constraint today is the labor. So they're usually running at least two operational scenarios. One is if everything is fine and we have the people, we are going to run 3 shifts with all our lines open. But we want to have another scenario if we have some shortage on labor. I mean, what happens if we can only run 1 shift, or maybe we can run 3 months with 3 shifts, and then we have to go down to 1 shift. I mean, what's going to be the impact in my inventory? Am I going to have stock outs? So they usually create multiple scenarios to have plan A, plan B. And we're going to try to see that on SAP during the presentation. So I said, step 1, the demand planner is going to go in and create the demand plan forecast. That's something very easy, because during the initial state of the project, we went in and we defined a predictive model for them, looking at the data. So now, when the demand planner goes in, usually they just click on a button and the system is going to create their statistical baseline. And then they have the ability to create building blocks with the different departments that are part of the process. So the building blocks, and the good thing of using building blocks is that information remains, so you can see what you changed from the statistical model. And the next month, when you're rerunning the process, you can see what you said last month on the lifts. So that's the first task they do. Once they have their demand plan in place, they will go to the simulation model. So when they open the simulation model, the first parameter that the user needs to load is they have to select a forecast version. So as I said, they could have multiple versions of the same forecast. They have to choose which one they want to run. They can select what is the starting month and how many months they want to run the model for. Usually they will run a full year or 18 months, rolling 18 months. Then once this data is loaded into the system, they have to select the date of the inventory that they want to take for the simulation. So that once that is processed, the user parameter window comes up. And here's where these are all the fast-moving parameters, because we have a lot of parameters, but most of them are more operational, and it's depending on lines and steps, and those are slow-moving parameters that the user normally doesn't change in scenarios. These are the ones that they are changing every day. So they're looking, as I said, there are 2 different production processes, the DTC and the retail, and they can change. They can open lines, close lines, change rates per month, and they can play with shifts. This is what they change most. I mean, how many for each plant, how many shifts can I work by month, and how many hours per shift, because they have breaks, so it's not always 8 hours, and they can run with or without weekends, and so they're different. Sorry, and the guy is the minimum weeks of supply is their safety stock, and this is their maximum. So they want to be sure that the optimizer and the simulation will give them a plan that will keep their inventory between these two levels, never below the safety stock and never up on the 6 weeks of supply. And this is looking forward into the demand. So depending on the demand, the weeks of supply is calculated. So once they change all the parameters, they would, so for example, here we're changing shift to 1. We know if there's going to be problems, so we're going to run a scenario with just 1 shift instead of 3. Then I need to run the solver. So I click and run the solver. Now AnyLogic is sending the parameters to Gurobi, and Gurobi is processing and is going to send back the solution. This can take up to 2 or 3 minutes, depending on how many months I'm running and how complex the scenario is. I mean, if I'm I'm reducing, I'm adding more restrictions, like having just 1 shift, and that's going to force the solver to find a solution. It's going to take a few more, not minutes, but it's going to be longer. So once this is done, the model is going to start running. This is not a visual model, so that usually doesn't come in here and look into charts and tables, because everything is being built dynamically, and so then the view is not very user friendly. But immediately after you started running, you can see the 2 different production processes running. You're going to see some previews of what's going on, what is the production, what is the demand for every month, and the retail production and the DDC production. DDC is very stable, and basically in DDC, if you cannot fulfill an order, you have to push it over. You're going to push it, and you have to change your delivery date. I mean, you cannot do any pre-production because it's work make to order. And retail, you can create inventory. So if you know you're going to have demand moving forward, you can start building that earlier if you're going to have some constraints. And because you're asking the system to work at a safety stock level, you can see that immediately in the first month you have a small demand, but you have a bigger production, because you're building your safety stock here in the first month. And then you see that because we restricted to 1 shift, then it's trying to pre-produce to be sure that it's going to be able to do everything in time. That's why the production is always higher than the demand in the first months. If you go into some of the more detailed views, for example, here you see 1 product, and these are the 2 lines of the weeks of supply, the minimum and maximum. You see it changing because my demand is changing, so it's always adjusting according to the demand. And the green line is the inventory. So we know that the inventory started ahead of higher than the safety stock. So then the system is consuming, it's trying to consume that inventory. That's why there's no production in the first months, because we're trying to get the inventory down. Once we get to the safety stock level, the system is, both the solver and the simulation is going to try to keep the production as tight as possible to the safety stock. So that's why it started producing after a few months. There's another product example where you start with no inventory. So this is probably new product. You had no inventory, so you start building up the inventory the first month. So that's why you have a larger production here, because you had to produce additional inventory just to get to to cover the demand, plus getting to the safety stock level. And then it's always very tight to the minimum weeks of supply. Once the process is completed for the 18 months or 12 months, whatever you picked, you can export this back to SAP. You can give it a name. So this is an identifier for the run, and you click on export, and this is going to go back to SAP. Later, once we go into the live demo, I'm going to show you some more details on the model. But as I said, this is not a visual model. So this is basically what the user would see during the process. So once you get back to SAP with the output, and this is step 3, where they can start looking at the different scenarios. Here you can see the full view of the 18 months of the rough cut capacity scenario, and you see the demand and the production for every month. The information is really processed by day. So even though the demand plan is a monthly bucket, when we get it down to AnyLogic, we divide it by day, because the production in AnyLogic is running by day. So when we bring it back to AnyLogic, we can show that by week or month or quarter, so that you can accumulate that information. So here, this is a monthly view of demand and production, and here's my inventory, always running between the minimum and maximum. There's a few months here where I'm going on top of my safety stock. And I also have raw material projections. So I started with a very high amount of inventory. So I'm trying to use that inventory on the raw material level. So the production is going to grow very slowly until we get to a safety stock level for the raw materials. The next view that they will look at is the inventory projection. So what's my inventory on hand, or my days on hand, and what is my cost of the inventory, and what is how my historical cost is going down. I started with a very high inventory, and this is one of the biggest results that they got from the system, is reducing the inventory to safety stock levels. That was a big saving for the company. They also have options to compare different runs and see what happened with 1 shift, what happened with 3 shifts. They have labor information. They can look at how many people they used in every single production step during the 18 months. And this is the machine usage. So if it's within the standard, what they call the standard or the premium capacity, how many hours I'm using every single machine. As I said, today their bottleneck is not their real capacity, it's their labor. So sometimes they are running always below the premium capacity because of the labor shortage. So as a conclusion, what we saw on after the project, they had some very interesting results, and in the data section, as I said, that having a single point of truth for all their analytics around the process was very important. On the demand plan, they improved their forecast error by a lot. They had very big numbers for their forecast errors. And on the supply side, for the first time, they were able to have an 18 rolling month of production plan with no stockouts, and they had their material requirements for the entire 18 months, taking into account the lead time and the minimum batches. So the AnyLogic is getting this information by SKU and by raw material from SAP, and when it's calculating and running, it's taking into account the lead time and minimum batch sizes. So the information, the material requirement they get is one step from being a purchase plan. So they just need to run that into their MRP and get their purchase plan. The reduction of the inventory was a huge saving for the company, and being able to look at the labor restriction projection. I mean, how is this going to impact? I mean, my inventory, my cost, my service. If now I don't have the people to run 3 shifts on all my lines. So those are the biggest savings that we saw and the customer by using the system.
Awesome.
I don't know. I think I ran out of time. I don't. Do we have a few minutes to see something online, or it's too late?
Yeah. So we're short on time. So any questions that you guys have, please feel free to send them to David directly, and I know you'll be happy to answer them.
Yeah,
and
sure.
thank you for the presentation. I know we all got a lot out of that.